Dear participants, today is the fifth lecture of this international workshop on digital image processing. And today we have a guest speaker, Dr. Amrita Aggrawal. I would like to introduce Dr. Amrita Aggrawal. She has completed her PhD in 2021 and she is working as a visiting faculty in the PG Department of Geography, Nagindas Khandwala College, Mumbai. Also, she is working as a visiting faculty for the Department of Geoinformatics in NK College, Mumbai, and she is a visiting faculty for Research Department of IBCom, Nagindas Khandwala College, Mumbai. She has 7 years of teaching experience and her area of expertise is environmental science, environmental management, tourism, geoinformatics, economic geography, and she is working with various GIS softwares and it includes ArcGIS, QGIS, etc. Also, she has expertise in the area of basic programming, GIS, GPS, handwriting analysis, etc. She has published various research papers at the national and international level in the reputed journals. Also, some books are at the credit of Dr. Amrita Aggrawal. She is a member of various geographical associations and INCA, that is Indian National Cartographic Association. She contributed as a resource person for in 5 training programs, workshops, etc. And she has also delivered various guest lectures in various colleges. And the if you talk about the focus of the lectures, you will find that her area of expertise is geoinformatics, that is remote sensing, GIS and GNSS. She attended various national, international level conferences, training programs and workshops. With this brief introduction, you might have got an idea about the credits of today's resource person, that is Dr. Amrita Aggrawal ma'am. On behalf of Devruk Section Prasarak Mandals, Atle Sapre Pitre College, Devruk, all the collaborating institutions and all the participants, I welcome Dr. Amrita Aggrawal ma'am. Madam, welcome on this virtual platform and I don't want to be a disturbance between you and the participants. So I request you kindly uh, enlighten the topic in the topic provided to you. I am sure your resourceful deliberation will be helpful to all the participants. Madam.
First of all, a very good evening to everyone present here, and thank you, sir, for the opportunity and the platform and the elaborate introduction you gave. I'm too junior to you, sir. You did not have to introduce it to me so much. Your blessings are enough. And coming to the topic for the day, we are focusing today on digital image processing, that is in that the sensor errors and corrections. Kindly give me a moment to share my PPT so that we can proceed with the deliberations. All right. So this is the elaborate topic that I'm going to cover and has been given to me for the day. So there are many errors and the ways to correct them when we talk of remotely sensed data. We shall first start with the introduction of what is a sensor. Because a sensor is a little different from a regular camera which captures pictures and photographs, maybe on your mobile or on the aerial photograph camera that we have mounted on the aeroplane, etc. A sensor is a little different because it processes in a different way. So when I talk of a sensor, it is always associated to a satellite. And where is the satellite? The satellite is always outside the earth, that is in the orbit of the earth. Now when we are in the orbit of the earth, it is very, very impossible to capture photographs of the earth using a regular camera, however digital it may be. So what we use is a sensor. In remote sensing, which is the art of acquiring information from distance, if you rely only on photographs and pictures taken from the sky, you will not be able to understand the features which are covered by higher features. For example, if there is a tree, it has a big canopy. And if you have certain objects or features or landforms which are hidden by the canopy of a forest or a tree, you will not be able to see that or identify them. But this is the advantage of a sensor, that it can capture even those landforms which cannot be seen by our naked eye or in a photograph, only because of the technology and the process through which it acquires the satellite imagery. So what is a sensor? Sensor is the object, or it is that part attached to a satellite which captures the satellite imagery. How does it do that? We will see in the upcoming slides. So now whenever a sensor captures the imagery, yes, it undergoes or it produces certain errors. Now these errors are of two types. The first error is because of some internal problem in the sensor. That is, now if your phone has a camera, if your camera is not working well, will the pictures captured will be good? No. So is this a system error? Yes. That is, the mobile with which you are trying to capture a photograph itself is not proper, itself is not working. Hence, the photographs are not coming proper. Therefore, whenever there is an error or a problem, a technical, a mechanical, or an instrumental problem in the sensor itself or in the satellite to which it is attached, it is called an internal error. Because it is the error of the system, the process, it is also called systematic error. At the same time, if the problem in the output, that is, if the problem in the satellite imagery is due to external problems, that is, disturbance in the atmosphere, like cloud cover, like a thunderstorm, like maybe a cyclone, due to which the clarity of the land is affected, it is called external error. Something which is external to the device, something which is externally affecting the quality of the imagery is produced, it is called external errors. So these errors are also called non-systematic errors because they are not related to the system. So such include atmospheric disturbances, steep terrain, like if you are trying to capture an imagery of a deep valley, very deep valley, which is totally dark because of the distance. Sometimes certain sensors are not able to reach so deep and hence they cannot produce a very clear imagery. This may come under external error. And there can be other problems also, like calibration issues or planning issues, like radiometric problems. Now what is a radiometric problem? Radiometric is related to resolution. So the flight is not planned, the satellite position is not planned properly. Now this is not the problem of the sensor, it is a problem which is outside the sensor. So all these causes or sources of errors are called external errors. Now, before understanding in deep what is an error, why is the error caused, how is exactly a remote sensing image is taken is important to understand. Now, in this process of understanding the concept of satellite imagery or remotely sensed product, the concept of EMR is very crucial. Now, what is EMR? EMR stands for electromagnetic radiation. There are certain principles of electromagnetic radiation which we need to understand and follow. In front of you is a diagrammatic representation of electromagnetic radiation, which is also called electromagnetic spectrum. Now, as the diagram suggests, one side of the wave, which is the wave shaped line, okay, one side of the wave you have the sun and one side of the wave you have the earth. It simply means that the wave is generated by the sun and it reaches the earth, but the pattern of the wave is not the same. So what is this wave? This wave is nothing but it is a ray of light. Now we all know that light is not a straight line. It falls in the form of a wave, it falls in the form of a ray. And the direction of this light is only one. That is, it starts from the sun and it reaches the earth. Until and unless it interacts with something in or outside the atmosphere of the earth, the light will continue to flow and a time will come when it will interact with something or the other in the earth and it will die. Yes. So why is this important to the concept of remote sensing? Because it is this light which helps us to capture remotely sensed data or satellite imagery. And when the light is not able to reach the land or the target area properly, okay, it causes an error. At the same time, when the light reaches the earth, okay, not all light is absorbed. Some of it is scattered in the atmosphere and some of it is reflected back from the earth back to the atmosphere, that is towards the sun. Now this reflected light is captured by the sensor and it is this reflected light which is captured by the sensor which helps to produce satellite imagery. If there is any disturbance in the light which goes from the sun to the earth or which comes back from the earth to the sensor, then it causes an error. Okay. Now, just to go a little deeper into the concept of EMR, we need to understand that just like the waves of the waves of the ocean are very strong in middle of the ocean and they become weaker near the shore. Why? Because the energy in the waves decline. And when the energy in the waves decline, what happens? The wavelength increases. And when the wavelength increases, the intensity of the wave with which it will come and dash the shore will decline. Yes, same phenomena, same logic is applied or is happening with the ray of light which comes from the sun to the earth. So you will see that near the sun, the wavelength is very small. The waves are very close to each other, which causes them to be very hot and intense. So if one tries to go near the sun, one cannot do that because it is very hot. It is very strong. If a person tries to see the sun with the naked eye, can you do that? No, because then you will come directly in contact with the sun's light and heat. So if we go near the waves of the sun, where the waves are very close to each other and very intense, we will automatically come in contact with very high temperature and we cannot survive. So this segment of the waves are actually called gamma rays. So now these rays are naturally present in the solar system, but luckily they don't reach the earth's surface, because if they had reached the earth's surface it would have burned down everything. So artificially we produce gamma rays in the laboratories to do certain experiments, or in the industries to undertake certain chemical experiments or chemical reactions, or if we want to sterilize medical equipments, etc. Because the heat that they produce is enough to kill any living being or organism present in the atmosphere or in the earth. Now, as we go away from the sun and near the earth, we find that the wavelength increases. That is typically because the energy in the waves is declining. So you can connect it to the potential and the kinetic energy. So when we throw a ball with our hand, where will be the highest energy in the ball? It will be near us because there it is highest energy. And as the ball goes far from us and falls on the ground, at that time the energy is declining slowly. And as the energy becomes nil, the ball reaches the ground. Correct? The same logic is applied here, that as the wave is near the sun, it has very high energy and very less wavelength. And as it goes far away from the sun, the energy declines, the heat declines, and the intensity declines. But it is between earth and sun that we have a very important band, which is the visible band. As you can see here, the visible light is having rainbow colors. So actually speaking, there are three main colors: red, green and blue. It is the shades of these three colors which makes the seven colors of the rainbow. And it is this band. Now these are called bands. It is this band which helps us to give colors to the remotely sensed data and observe objects around us. So, my dear participants, what I want to bring to notice is that it is this difference in the wavelength which is captured by the sensor. It is this light which reaches the objects on the earth and it is reflected back. The reflected back light is captured by the sensor and it produces something called as pixels. Now to define pixels, I can say that pixel is the smallest part of an image. I repeat, a pixel is the smallest part of an image. Now what is an image? An image is then the remotely sensed product in the form of satellite imagery, aerial photograph, or even the photograph that you take from your phone. Now have you ever zoomed your photograph? Do you find that it gets blurred after a certain point of time? And when it gets blurred, do you find that some small boxes can be seen? I would like the session to be interactive, please. Kindly talk because I'm presenting my presentation. I cannot see the messages you must be posting. Can I
Yes, ma'am.
request? Yeah. So have you ever zoomed your photograph and does it appear like a grid of boxes?
Yes, ma'am.
So that one box is called a pixel. We, in our slang language, we say pixelate ho gaya.
Yes, yes.
Yes, we also say pixels fat gaye.
Yes,
Correct?
ma'am.
Yeah. So that is the pixel. It is the smallest part of an image. But now what happens in a satellite imagery is the pixel is made up of,
Yes, yeah.
yes, in satellite imagery, any imagery is made up of pixels which looks like a grid of rows and columns. That's how the checks will appear, no? Now each pixel is made up of a value, which is also called digital number, which I'm going to cover elaborately in my next lecture. Now this value is what? This value is the reflected light that is captured by the sensor. So it is called reflectance value. It is called reflectance value. Now this value of reflectance ranges between 0 and 255. Okay. If the value is 0, it is black. The color will appear black like this. Black and white and gray. And if the value is 255, which is the highest, it will appear white. I will explain why. And in between it will appear gray. But definitely the values are not confined to just perfect 0, perfect 255 and perfect center. It will be somewhere in between. It will also be decimal values. So depending upon the value, the color will be given to the imagery. Earlier we had only black and white or grayscale imageries. Now we have colorful imageries also. So it gives according to the value. Now how does this value come? So you have many objects on the earth surface. You have water bodies. You can see a satellite image that I've given here. You have water bodies, you have mountains, you have built up area, you have agriculture, you have vegetation. In water bodies also you have fresh water bodies, you have salt water bodies, and there are many more such land uses and land covers present on the land and even in water. Yes, now each object on the earth's surface is made up of different components. Like for example, water is made up of certain chemicals and it may have certain gases. Okay, a mountain is made up of soil which comes from the rocks. It may be snow covered, it may be covered with trees, or it may be completely barren. The land may be having agriculture. Agriculture could be of various crops. It could be paddy, it could be cotton, it could be maize, it could be something else also. A forest, for example, will be having trees. These trees will belong to various species. So there could be any wild tree or there could be any tree which is found normally also in the urban areas. Yes, then we have built up areas. So built up areas that is made by man can be made up of bricks, they can be made up of concrete, they can be made up of say for example glass, they could be made of wood and etc. So what am I trying to put forth is there are various types of objects present on the surface of the earth, and each object has a different shape, has a different size and is made up of different materials. Now each shape, size and material has different capacities of absorbing light and reflecting the light. For example, an area which is covered by snow. What do you think? If light falls on a snow area, will it absorb the light or will it reflect it back?
Reflection.
Very good. Can you tell me why? The color of the object also is important here. A hint for you. What color is snow? White.
Reflectivity of light.
Because they are made up of such particles which absorb light to the minimum and reflect light to the maximum. So in a desert, sand is made up of what? Very dry particles, and it has limestone pieces. That's why you get glass from desert sand, no? On a beach also it is made up of calcium carbonate particles which also are white in color. They absorb less light. Yes, on a beach, that's why you find that it will shine. In water, you have salt. Salt again is white in color. It has less absorption and more of reflectance. So such areas, even in an imagery, when you will see white patches, when you will see white lines, when you will see white areas, you can identify that there will be some object which is reflecting more and absorbing less. Now, if there is more reflectance, the value will be near 0 or 255. If the object is appearing white, that is it is reflecting more, the value of such pixels which is showing that object will be near 0 or near 255.
255.
Yes, perfect. I just said, and as the diagram depicts, the darker the color, that is, the more the absorption, the value will be near 0. And the lighter the color, that is, more the reflectance, the value will be near 255. The diagram in front of you will help you remember this, that 0 was written in black and 255 was written in white. So these are the extremes. In between, suppose the value is 175 or if the value is 200, 200 would also go on a lighter shade. And if the value is say 20, it will definitely be on a darker scale. So pixel, each pixel is having a color. The color comes from the pixel value and the pixel value comes from the reflectance that it captures. What captures the reflectance? It is the sensor which captures the reflectance. So in short, we can say that each satellite imagery is made up of pixels, which is called what data? Is it raster or vector?
Raster.
Yes. It is called
Raster,
raster
ma'am.
data. Yes. It is called raster data. Now raster data is made up of pixels. This is the most common definition given of raster data, and it is the pixels which differentiate raster data from vector. Vector is made up of point line polygon and raster is made up of pixels. Pixels is nothing but a pixel is the smallest part of an image and it is represented with rows and columns. Is it clear till here?
Yes, ma'am.
Any doubts in the electromagnetic spectrum? I have just touched upon it. It is a very deep concept though. But what I tried to put forth is that light comes from sun to the earth and not all happen with when the light comes. It interacts with the atmosphere. So at that time either it is absorbed or it is scattered or it is reflected back. So what is absorbed is lost forever. What scatters in the atmosphere is there somewhere in the atmosphere, which helps us regulate the weather, day-to-day weather. So some days you feel very hot, some days you feel very cold. It is only because the light which is present in the atmosphere. So it is important. Third is reflectance. So the light which is not absorbed by the objects, light which is not lost in the atmosphere, it is reflected back. When it is reflected back, that reflected back light is captured by the sensor. So the amount of reflectance is captured by the sensor and small land parcels. Now what is a land parcel? Land parcel is the smallest part of land. Just like pixel is the smallest part of an image, parcel is the smallest part of land. So for each land parcel, the sensor captures the as pixel in the satellite imagery. Clear? The pixel values of a proper satellite imagery that you have downloaded or purchased from ISRO or any other organization like this, you have to open it in a proper software like ERDAS Imagine or any other GIS or remote sensing software where you can go to the attribute table and you can see the pixel values. Now these pixel values are crucial because they help us understand the objects, they help us make the terrain model, they help us make the elevation model, they help us do the altimetric analysis, contour analysis, they help that the features will be identified in the software and the analysis will be done. Okay. Now, so what if I tell you that I give you an imagery, but certain pixels will be missing from that? Do you think you will be able to interpret the imagery in that case? You know what is interpretation, right? Yes, what is interpretation?
Interpretation is to know the explain the pixel. What is the pixel is representing?
Very good. So if I give you any map, any diagram, any chart, any figure, when you're writing a detailed explanation of what it is showing and what it is understood from that chart, graph, figure, map, whatever it could be, it is called interpretation. So it is a detailed analysis. Now, whenever a satellite imagery is given to us, and if it is not complete, that is, if some pixels are missing, definitely that means some information is missing. So, if it's, for example, Mumbai, okay, three lakes. Okay. Now what if I download a satellite imagery of Mumbai and the pixels of one of the lakes is missing? Will I be able to understand what the area is? If I am a layman, I have never seen the map of Mumbai and it is the first time that I'm downloading a satellite imagery of Mumbai. And if I get an imagery in which pixel values are missing or pixels are missing, do you think I will be able to understand what the map is trying to show or what is the interpretation of the imagery? Will I be able to come out with outputs?
Yes, ma'am. Ma'am,
No.
because association we can also done now. If other pixel nearby pixels are showing water body, so we can say no middle of the
What if
pixel a
the
pixel.
entire area is only missing? What if there is Powai Lake, for example, and the entire lake is missing? How will I understand what it is? See,
No,
one
we
or two
we
pixels are
not understand, ma'am.
yes.
We can't imagine.
Yeah. So if I don't know the area, and suppose if there is an agricultural area, okay, and in an agricultural area, there are small crop fields. So suppose in one part of the land I am growing wheat, in the other I am growing maize, in the other I am growing barley, etc. And the pixels are missing of the boundary in between. Okay. And not one line, two or three lines are missing of the pixels. I will not be able to identify the boundary and the interpretation will be incomplete. Definitely what the earlier participant said is right, that I can reduce the error. But that only I have to understand in the next part of my presentation, that what type of errors can be faced and how can we reduce them in case of understanding the imagery better. And why do I do that? Because one satellite imagery is very costly and which the one that is available for free is available with error. Now if I want an error free imagery and I want only for a small analysis, it is very difficult for individuals to always keep ordering better imagery. And it is also possible that you might not find the new imagery in time. Suppose you are analyzing the data or an area for every February. Suppose you are doing it for 10 years. So 10 Februaries ka you are collecting the data. Now that means you will want the satellite to pass over a data on that particular day of every year. Correct? Now you have data for 10 years, but 1 year is missing. Can you go back to the year in reality and ask the satellite to click off imagery and send you? No. But the satellite imagery is now with error. So what you have to do is you have to identify which error it is and try to reduce the error so that your interpretation becomes better. Okay. Now this is all about pixels and from where and what is actually error. Error is when some or more pixels are missing in the satellite imagery and which is making it difficult for you to do the interpretation or to identify or to undertake analysis. So when pixels are missing, values are missing, your analysis also becomes very difficult. Errors today. Tomorrow we will be looking at, in the next lecture we will be looking at the external errors. So there are four internal errors which we will be focusing upon. The first is random bad pixels. The second is line or column dropouts. The third is line start problems and the fourth is end line stripping. Now, the name itself gives us some idea about each error, but I will be covering the errors and the ways to correct them in depth here. The first is random bad pixels. That means, as you can see, imagery here, this is an imagery, and in which we have zoomed and shown here that some one or two randomly pixels are missing here. Okay. Now, actually, if only one or two pixels are missing, it is very easy to identify what it could be because out of a big crop field, if one pixel is missing, it cannot be some other crop. If it is a wheat crop, it has to be wheat. But what happens is whenever you're doing some raster analysis like slope, aspect, hill, this, that, so a gap in the information will not let you generate the output. Suppose you are making a digital elevation model. Okay, and if one or two pixels are missing randomly in the imagery, it is difficult to generate correct output. So what you will do, you will use the averaging method. That is, if, like she said, If the nearby values are say 5, 10, 15, then even the average of 5, 10, 15 only will be the value of this pixel because it falls between 5, 10, 15. So that is called the averaging method of pixels. And when you have random pixels missing in the imagery, it is called noise. Okay, but if only a few, like 1 or 2 pixels are missing, like you can see here in the zoomed imagery, it is called short noise, and technically it is also called dark poke marks. So see, what if a layman is interpreting the image? He will say it is a water body. But we know as experts that they are not water bodies, they are missing pixels. Is it clear here? So randomly, 1 or 2 pixels are missing in the imagery. They are called random bad pixels. Why? Because such pixels are not having value and they are bad for our analysis. Okay. Now this averaging can be done manually or automatically. Here 1 pixels were missing, but here the entire line is missing or entire row is missing. Now
Ma'am,
when this happens, like I gave you an example, if
ma'am, why the random error is occur in sensor? In what types of situation in sensor it is occur?
okay, so like I said, the sources of errors. Now these are internal errors. That means these are system errors. So sometimes the reflectance is so less that it could not catch, or the sensor missed it, or there was some disturbance in the satellite or the sensor that it could not catch it, or there was some problems with the calculations that the sensor could not calculate and it could not produce it. So some error with the sensor or the processing in the sensor due to which these errors will be produced. As I said, we are looking at internal errors, and internal errors are produced because of the problem in the device or problem in the calibration. Now what do you mean by calibration? Calibration is adjusting the sensor or the camera as per the point you are aiming at. So now these satellites are controlled by people on ground. So if they make some errors in the settings of the system, then it is coming under internal error. And what you saw now is the first internal error. So this error, that is random bad pixels or line or column dropouts or line start problems or end line striping will appear only when there is a fault in the sensor or in its machinery. Is this clear?
Yes, ma'am. Then we should go
Yes.
with different interpolation. No.
Yeah, that is, yes, that is what is averaging method or interpolation method. So like just how you do in interpolation, whatever is the nearby value, you take the same value, or if the value falls in between two different values, you take the average of the two different values and you take the value here. For example, if this green pixel is a missing pixel, you take the value of the nearby pixels, you take the average of that and you assign the value to this pixel. So it becomes a good pixel from a bad pixel. That is what is called averaging method. Now if a few pixels, so one pixel, but if a full row or a full line of pixels is missing, I can miss out on very crucial information. Okay, now how do I then, now what is it called? It's called a bad line or a total column dropout. Okay, so why bad line? Because it is missing value, so it is bad for my analysis. Now, when does this happen? When, see, we know that the data is collected by sensor which is attached to a scanner, and a scanner has a definite path of movement. So it will move from left to right, then it will take a turn, then it will come from left to right, then again from left to right, then right to left, left to right, right to left. Now suppose when it was coming from left to right on this part, there was a problem in the system which we realized later. Okay, so this entire path was not captured as it should have been captured like other paths. Or if it was when it was moving from up to down, down to up, some problem happened here and it could not capture the entire path or the entire swath or the entire line. It is the one and the same meaning. Then such error will come. Now this problem would have been in the system, not on the earth, but in the system itself. Maybe there was a failure, maybe it fell short of power, or maybe there was some system failure due to which it could not take. So this problem will appear. Now how to solve the problem? Now since only one line is not appearing and the lines around it is having pixel values, even it can be removed using the averaging method. So the average of the nearby pixels can be taken and the value can be assigned here. So what will happen? All the missing pixels will come to the picture because of the value you are assigning it, and they will become good pixels from bad pixels. So the same logic or the same method which we applied in one pixel, we can apply to the entire line also. It is also called line averaging method. Is this understood? Interpolation and averaging is the same. Interpolation, you do it on a piece of paper with the help of plotting lines and values, and averaging, you just take the values, you calculate the average and you plot it there. It is one and the same meaning. The output will be the same. Any doubts here?
No, ma'am.
Good. Then comes the third error, that is the line start problems. Now, as I said, the scanner is going to move from one direction to the other, then it will take a turn and then it will move from this direction to this direction. Now, sometimes what happens is when the scanner is taking a turn, at that time it is not able to capture the data properly, or the data becomes blur because of the changed movement of the scanner. At that time, sensor fails to take the information of the starting and the ending locations falling on that line, which is called line start problems. That is, at the beginning and at the ending of each line, the data will be blurred. And this happens very often because no place on the earth can be covered entirely only by the sensor taking it only once. The scanner has to move several times on the same area to be able to produce the satellite imagery. So this error is bound to happen and very common to happen. But it was happening much in the earlier satellites. In the present era, where to avoid such data loss, we have improvised the satellites, we have improvised the sensors so that the error is minimized to the maximum. But 100% error reduction is not there. That is why later we have to reduce the error. Now how do we reduce the error? Simple horizontal adjustment. So we know that each area is covered in several images. So that is called a stereo pair, where there is some overlap in the areas in the two imageries produced. So what you can do, you can adjust, just like you play jigsaw puzzle, you can adjust the overlapping imageries in such a way on a table or in the software that you are able to identify the starting and the ending points, and you are able to identify the objects also. Okay, so that you can do after you print the imageries, or if someone is continuously controlling the imagery, the sensors and the scanners, once it takes a turn, it can be adjusted and then only started and sent for further capturing of the data. But every time someone sitting on the computer and controlling the satellite is also not possible. Therefore, this error will happen and is very common. That's why you will find sometimes the boundaries or the edges of an imagery are not as clear as the central part of the image. That is typically because of this problem. Is it clear?
Yes, ma'am.
Okay. And the last one is n-line striping. Now this, आपका कभी printer खराब हो जाता है and you still print something in the printer, you will always find that the printout is like this. Yes. Does it look like a printout coming from a bad printer?
Ma'am, actually your presentation is not visible, ma'am.
How come?
I
Yes,
don't
ma'am.
know.
To me also not visible.
From beginning it is not visible.
No,
No,
ma'am.
ma'am.
No,
Starting it
no,
was
no, no.
visible.
Okay, no problem. I will share again. No problem, I will share again. Okay, some are saying it is visible, some are saying it is not visible. It is okay, I am sharing it again. Is it visible now?
Yes,
Yes,
ma'am.
ma'am.
So could you see line start problems ka diagram?
Yes, ma'am.
Okay, now is it visible?
Yes, ma'am.
Great. So this picture can you see?
Yes.
Okay, so
Screen
does
is
it
covered.
look like a printout from a bad printer is what I was asking. As if the
Yes, ma'am.
cartridge
Right.
has faded and the printout does not come properly. Kindly
Yes.
mute yourself. So when an imagery is produced like this, okay, it is called end-line striping, wherein several very thin stripes of the imagery are missing information. But now what happens is, if there is one column like this, okay, it is easy to reduce the error and it can be done faster also. But what if there are several such stripes in the imagery? And then whatever processing you do, it will not happen. If you want to calculate the elevation, if you want to do the slope analysis, aspect analysis, it will not allow you because the values are missing. So such errors are coming when the sensor fails completely. It is not working properly at all. There are calibration issues and there are issues with the power, etc., or the sensor or the scanner have lost their life, due to which they are not able to capture the reflectance properly, and it is happening frequently. So the entire area is not covered properly. In fact, if you see in depth, you will find that the information which is observed also is not very clear. Okay, now sometimes it also happens due to the nature of land. Okay, so some sensors are meant only to cover water bodies, but we are trying to cover a desert also. So when it is meant to understand only water bodies, it will not be able to understand desert sand. So in that case also it will give a very blurred image or a very striped image like this, because it does not have the potential to capture the objects which are present on the land. So this problem is a system problem, but it is created by humans. So if I am a controller of a scanner or a sensor, I should know which scanner is suitable for which object, and accordingly only I should design my flight so that it can capture the most appropriate variables. Okay, so the result of such errors will be an image which is giving wrong information. It can show objects which are actually to be shown in dark color as white color. It can show certain objects as gray which should not be shown in gray. So how to reduce such problems is only by generating a histogram, okay, which can be done in the software at a faster speed, and then that histogram you can find out the missing values. So when the histogram is created, what is a histogram? A histogram is a continuous bar graph. There are no gaps in the bar graph. So when the software is going to create a histogram for this imagery, it will automatically fill in the gaps in the values, and you will understand which value is located where. So in that case, you will have to understand the objects only through the help of the histogram, and you cannot understand it through the imagery alone. So this is the most difficult error to reduce and to understand the objects. In the previous errors, you could at least adjust and understand the objects. Here you could do the averaging and understand which pixels they are. Here also you could do the averaging and understand which lines they are. But in this one, you cannot rely on the imagery. You have to totally rely on the histogram which is generated by the software. And suppose if suppose this missing one is falling between a snow area, obviously it will create a histogram of the snow area for this also. So I have to understand that if two columns are snow and in between this is falling, it will also be a snowy area only. But I can do that for one or two objects. For the entire imagery, I will have to rely on histogram for easy analysis of the entire area. Is there any doubt here? Is it understood? Because it brings to the end of my presentation.
Yes, ma'am, theoretically it is clear, but practically, if it was possible, then it could be much reliable for this. The last one, the line stripping.
Okay, now practically I will have to have data to show you, but definitely I can show you, I mean, I can draw a histogram and I can show you how it will, I mean, I can demonstrate it. Okay, so I will just try that out if that is possible here. Okay, so I will take some data here first. Okay, now since it is not a geospatial software and it is not associated to any attribute table here, okay, it is showing with gaps. But this is an histogram where I have, connected all the bars together. Now, for example, if I ask you, if this value is 12, if this value is 13, and if this value is 15, what will be the value of this missing place?
Must
What
be
will be the,
14.
yes, what is that?
Probability 14 is 99%, we can say, as
Yeah, because that is the average of the two values. Here also it is the average of the two values. Now in a geospatial software, that is GIS software or a remote sensing software, it will automatically make the column for the missing value also by taking the average. Okay, now what I meant to say is, if you have only one pixel missing or only one line missing, you can do it manually also. You can yourself understand what the place would be. But in case of such imageries, where after, every alternate strip is missing or every fourth strip is missing, for example, doing it manually is a task. So what do? We go to raster analysis and we generate a histogram there. You can also generate a line graph, but you can also generate a histogram there. And there it will automatically fill in the gap for your easy interpretation of the data. Now in such error reduction, you must know the spectral signature of the phenomena, the spectral signature of the objects. What is a spectral signature? Spectral signature is the percentage of reflectance for each object. So each object has a definite value. So snow will be between 200 and 225. Water will be somewhere between, if it is polluted water, it will be somewhere between 100 and 0. If it is fresh water, it will be near 100. If it is salty water, it will be between 100 and 150, etc. So when you see the values of the missing pixels also, you can identify the objects with the help of a diagram like this. Is it somewhat understood?
yes, ma'am. That means to apply these types of analysis, enough experience we have need that the also the reflectance value of each element, like these things, no, ma'am.
Yes, yes. Hence, I always say that whenever you want to do raster analysis, you must always have a proper satellite imagery downloaded as an imagery and not as an image. Please understand that there is a difference between an imagery and an image. Image is any image that you download from Google, for example, like this. So I can go to, this is my Google Chrome. I can just type satellite image. I can go to images. Okay, satellite imagery. Okay, Now if this is a satellite imagery, I will save it as an image on my desktop, for example, and I can open it as JPEG. Okay, this image will can be clear. You can understand the objects, you can do the interpretation, but you cannot run raster analysis. Whereas if I download an imagery from Bhuvan through its free data, okay, like for example, I go to the open data archive. After logging in only, I will be able to download. Suppose I want to make a digital or I want to make land and terrain models and I want to make it. So I will select the tiles. I want to select several tiles. Okay, so I selected 3 tiles and then if I want to download them, yes, I go to next. See, I can see the information of all my slide, all my tiles that I've selected. Now these are what satellite imagery tiles. Okay, so one tile will cover this much area. Yes, and I can also select which date I want the data to be downloaded for. And suppose if I click on metadata, I will get all the technical information about my satellite imagery. If I click on view, see I can view my satellite imagery. Okay, and if I click on download, it will ask me to log in. So as soon as I log in, I can download the imagery, and this image you cannot open in Paint, you cannot open in Photos, you cannot open in any other software. You can only open it in GIS or remote sensing platform. Yes, and then when you go to the attribute table, you can see the pixel values there. Okay.
Yes,
Yes.
ma'am. In GIS software, ArcGIS, QGIS, and ErrorDes, is there this application is available to remove the line error and
Yes, yes, yes. Error reduction is available everywhere.
okay, okay,
Error
because
reduction is, and for that, you should first know the basics of it. Theoretically, you have to understand, and then practically, you have to apply. In all these software, you have tools and plugins, and just in a jiffy, you apply, and it will reduce the error. So it comes under processing.
that means, ma'am, this all of these things are pre-processing before the image analysis, no, ma'am?
Yes, to do a proper analysis, to do a proper interpretation, you have to first correct your data. Like for example, you go to the field, you collect socioeconomic data of slum. Okay. Now what happens is everybody cannot answer in the same way. So you just note down their answers. Then you come back and you structure the data properly so that you can prepare graphs. Yes or no? Correct, no?
Yes,
Same
ma'am.
way, whenever you want to run analysis on satellite imagery or even on aerial photographs, it is important to reduce the noises. Noises means errors or disturbances which are hampering your smooth analysis and interpretation. Because, I'm repeating again, because even if one pixel value is missing, your output will not be generated properly, whichever output you want to generate. Suppose you want to make a digital elevation model. You will not be able to make it properly because the missing pixel value is present there. Yes. So
Yes,
these are errors and these are the ways in which you can reduce them. So see, software may you will command, it will do. But what is the software doing? You have to know now. Like for example, Excel may you are making this graph, but if someone asks you how is this graph made, you know how is the graph made. You make the x and y axis and then you plot one by one, and then we have applied it in the software, correct? So same way, once you know the theory behind the errors, you know the sources and you know how software is reducing the error, you can explain it to someone else also. And if the software is not giving the correct output as you want it, you can even change the command that you're giving in. That is why understanding theory is important first.
yes,
Yes?
ma'am. And another one thing, as
Yeah.
when we are going to image analysis, such as 10% is cloud we are considering, and theoretically that 10% is not create any big problem, such as is there any threshold line for this the line stripping and the pixel
See,
gap?
you have to first understand which season you are taking. If you are taking monsoon season, cloud cover will be very high. You cannot have a threshold of 10%. If you are going for winter season, then obviously the cloud cover will be less. Summer season also the clouds start forming. So I would like to tell you one thing. If you are going for, suppose for example, you're going for land use land cover analysis, February is considered as the most ideal month of capturing satellite imageries because at that time the cloud cover is minimum and there is not much atmospheric disturbance also.
Yes, ma'am.
Yes.
No, ma'am, actually, I want to know that how much this line error and the pixel missing error I can consider that if there is too much error, then there should be one threshold line, no, that after this threshold we cannot consider this image.
See,
If it
any
be
error,
uh,
10% definitely you can consider. You should go for a 0% error, but maximum up to 7 to 10% is what is considerable because 90% becomes maximum, right? So 10% you can leave. But after you get the data, you should try to remove that much error also. Because what if in that 10% only you are having your main landform or phenomena which you are concentrating at. And I would like to add one concluding mark here that if your area of study is accessible, please, even after reducing the error or even if you have an error-free imagery, undertake ground truthing. Now, what is ground truthing? Due to which it is giving a bad pixel or a black pixel. So you have identified it as a water body. If better analysis, you must always visit the ground if possible and then cross check whether what you have understood or not is correct or not. Now in today's era, you don't even have to go to the ground. You can do it through Google Maps or Google Earth also. So you can see whether what you are trying to understand is the same as it is shown in Google Earth or Google Map. Is the best platform because a lot of data is available for free and you also have a lot of processed products also. You already get ready-made LULC maps, terrain maps, vegetation maps, etc. But if you are going outside India, then you can go to USGS Globis. But then there are certain restrictions on the resolution on each platform that you download. So if you are looking at a very high resolution data, it is advised you purchase the data from ISRO. But if your resolution is not a barrier, like for example for LULC, if you can go up to 30 meters resolution, it is available on Bhuvan, so you can definitely take it from whichever website you are looking at. India में हम ज़्यादा काम करते, Bhuvan is the best. I have also downloaded it from Bhuvan only, and then I have processed it for LULC and I have got best results.
Thank you, ma'am. Thank you.
ma'am, another
Welcome.
thing, I have made one land use land classification, but I have experienced that from the Google Earth engine, which we have getting the corrected image, it is giving much erroneous result than the USGS and other. So why these types of the misclassification or the image problem is coming? It is for
It is
the
the difference in technology.
okay.
We know that India is advancing, but we also know that US has already advanced. So it is a difference in technology, definitely.
Okay, ma'am. And another thing, if I run the same machine learning in ArcGIS, it is giving the different output. But
Hmm.
QGIS also it is different, same algorithm, but there is little bit difference in output. So it is due to the software to software it will vary, or what
It is
I.
due to the decoding from the software. So ArcGIS is a definitely higher version, higher end software. So if you are doing something which is really, going to be applicable to the society, etc. So, and it is not only for representation, use ArcGIS. QGIS is a baby and you cannot expect the same output from a baby as from the father, right? So some discrepancy will be there, but I think that should be negligible because it will be, I think, in decimals. It will not be creating a very big difference actually. So you can go with whatever is available to you. That is why in the methodology we always mention the software that we're using, so that tomorrow if someone questions, we can say that, see, this is the software I've used and this is the output I have got. So if there is any discrepancy between two software, it is typically due to the features of the software. And also used to if you can upgrade your QGIS, the latest versions of QGIS are having least discrepancy between them in ArcGIS. Yes, someone has raised hand. Sakubai, yes madam, do you have anything to ask?
Ma'am, another question that is not directly related to this topic, but if I use 30-meter dam in Himalayan region for study the Himalayan region and wanted to evaluate or find out the how much it is per year increasing or decreasing or subsidence or upward movement, then it is possible to from the 30-meter dam to it is detect the elevation fluctuation per year, because as my knowledge it is little bit difficult from the dam to detect such types of analysis.
See, it again depends upon how good is your pixel values there. Because the source from where you've downloaded the data should be reliable. The resolution has to be very good for such a detailed analysis. So if you're not undertaking a very big area, and if you can purchase a proper imagery with a higher resolution, then I think your analysis will come out better, because the Himalayan region is a very densely mountainous area, and there are certain peaks which will not even be counted in a poor resolution imagery. So if a high resolution imagery you can find and then run such analysis, your outputs will be better.
Okay, ma'am. Okay, thank you,
There
ma'am.
was some question put in the chat box. Which satellite imagery we can download from Bhuvan portal for LULC analysis? It is definitely LIS. LIS 3 is the most ideal imagery that is used for LULC. It gives you a higher resolution and it is enough for a LULC analysis which we undertake, because we don't take pixel by pixel. We take a generalized area when we're talking of LULC analysis, since it's always a bigger area which is involved in it. Yes, those who have raised hand, please ask your questions. It is a combination of both. See, what you should do unsupervised classification first. Okay. And then do some ground truthing. And then wherever you find a problem, you change the range of the classification so it becomes supervised. So it is a semi unsupervised or semi-supervised classification. It should always be a combination of two. Whenever whatever you're doing on machine, no, it should always be semi-supervised is what I feel. Because entirely you cannot rely on the machine. It only relies on calculations, and manually doing everything is not possible. So let the machine give the outputs and then you intervene. So it becomes semi-supervised classification. Someone said wonderful presentation. I really appreciate your comments. Thank you so much. Patil sir, I hope I have done justice to the topic and I have been able to
Definitely,
answer all the
definitely.
questions.
I can say that your lecture was really interactive, and I also
Thank you, sir.
appreciate the interaction at the end of participants. Today they have asked many questions, and it is expected. It is expected. And dear participants, if you get the data and if you perform the practicals, in future you can contact Dr. Amrita Aggrawal ma'am. She is very much cooperative. She is very much cooperative.
I
Just
have posted my
yeah,
email ID in the chat box, sir. You all can anytime, send me a query and I shall answer as soon as possible at my end.
yeah. Dear participants, I hope there may not be much more questions right now. Okay. Tomorrow there will be session and Dr. David will deliver the session. Actually, his session was the second session, but due to unavoidable circumstances, he couldn't deliver his lecture. And that rescheduled lecture will be delivered by him tomorrow. And from Monday onward for next 3 days, again Dr. Amrita Aggrawal will be with us and she will cover entire image processing part. I mean the errors and its rectification. And this is one of the most important topic in image analysis. Uh, Actually, you can download the software. That is, Saga is the best one in open source. But ADAS Imagine is the, as Amrita Ma'am said, it is like ArcGIS in image analysis. ADAS Imagine is better. But again, it is a proprietary software. Only the academic institutions can afford this. For personal use, either we can search for open sources or you can say free sources or their license, tenure license they are providing. Either it is ADAS or ArcGIS. You can search for the same on Google and you can use it. Okay, our basic motive is to provide the grounds which required for the image analysis. Okay, I hope our workshop is providing this fundamental to all of you. I think, shall we conclude, ma'am?
Yes, sir.
Hello.
Ah, yes.
So we need. Hello.
Yeah, Tamir madam, please provide the vote of thanks.
Yeah, sure, sir. Respected Dr. Sardar Patil, sir, Vice Principal and Head of the Department of ASP College, Devruk, and the source person, Dr. Amrita Aggrawal, ma'am, and all the participants, good evening. Today, I feel incredibly honored and privileged to have been allowed to extend a vote of thanks on this digital image processing workshop on behalf of organizing committee. First of all and foremost, I thank our special resource person, Dr. Amrita Aggrawal ma'am, for very informative and interaction sessions. And also thanks to all the participants. Thank you, ma'am. Thank you so much.